Hey, what's up, all? This is Tucker Hammonds. I'm the co-founder of Higher Blue, and this is the second video in our NATE core exam construction math review that focuses on angles and triangles. So using the universal properties of triangles to calculate things like distances and angles comes up all the time in both HVAC and construction. Understanding these properties of triangles can be used to determine lengths, angles, and supports for a lot of construction materials to build decks, bridges, etc. Due to the many applications for building, a basic knowledge of triangles is really important for a lot of HVAC jobs and construction jobs. So you all know what a triangle is, but just to define it, triangles are shapes with three straight sides and three angles. The sum of all three angles is always 180 degrees. And the main three triangles in terms of side lengths are the equilateral, isosceles, and scalene triangles. Every triangle typically is represented by three angles labeled A, B, and C, and then the lengths of each side of the triangle are going to be lowercase a, lowercase b, and lowercase c. Lowercase c is always going to represent the hypotenuse. The hypotenuse is the longest side in a triangle. So for example, in the bottom left triangle here, the hypotenuse would be this long angle across from the 90-degree angle here. So the equilateral triangle has three of the same sides. So A, B, and C all equal each other, and therefore all the angles equal each other as well. So every angle is going to be 60 degrees to make up a total of 180 degrees. The isosceles triangle, two of the sides are going to equal each other. So in this example, AB and AC equal each other, but CB is not equal to the other two sides. And then finally, the scalene triangle, none of the sides equal each other in length. And then down below, we have another way to describe triangles by their angles. So these are the angles that are across from the hypotenuse. The right triangle, which is probably the most important triangle we're going to cover, has a 90-degree angle. The obtuse triangle, the angle across from the hypotenuse is greater than 90 degrees. And then for the acute angle, all angles are less than 90 degrees. Okay, so now we're going to cover the 3-4-5 rule, which is a characteristic that applies to right triangles. So right triangles are commonly used in construction for designing layouts and building foundations. Typically, we label the sides of a right triangle, as I said, as A, B, and C, and the hypotenuse is always opposite to the right angle. The right angle being 90 degrees. So the 3-4-5 rule is a really handy trick that has been used in construction for hundreds of years, honestly, before calculators were a thing, before rulers were a thing. It's a simple rule of thumb for right triangles that basically states that triangles with multiples of 3, 4, and 5 units are always going to be the same ratio as a 3-4-5 ratio. So what does that mean? If you look here, right, we have a triangle where two sides, A and B, are 3 inches and 4 inches, and those can be interchangeable. But then the hypotenuse would be 5 inches. So basically that ratio holds for any proportional triangle length. So say you have a side that is 9 inches and 12 inches. Those are both multiples of 3 and 4. So the hypotenuse would be 15 inches. This also works for 15, 20, 25. And then another example that I'm going to show you is right here, where you have a right triangle with a side that is 8 inches long and a side that is 6 inches long. So this follows the ratio of the 3-4-5 rule, right? Because 8 is a multiple of 4. 4 times 2 is 8. And then 6 is a multiple of 3. 3 times 2 is 6. So you have the 3-4-5 rule here. And then you have the 6-8 X rule, right? So what is the hypotenuse when you have a side of 6 and 8 following the 3-4-5 rule? Well, that's simple. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So in this case, C equals 10. All right, so I'm going to expand on that 3-4-5 rule even further by going through the Pythagorean theorem. All right, so now that we've covered the 3-4-5 rule, we're going to go over the Pythagorean theorem. Basically, the 3-4-5 rule is made possible by the rules established in the Pythagorean theorem. What is the Pythagorean theorem? The Pythagorean theorem is a handy tool that states that if you know 2 of the 3 sides of a right triangle, you can solve for the third side of the triangle. So I'm going to repeat that. If you know A and B, you can always solve for C if you don't know the length. If you know A and C, you can always solve for B. And then if you know C and B, you can always solve for the length of A. The theorem says that the square of a hypotenuse is equal to the sum of the square of the two remaining sides, in this case, A and B. The equation is A squared plus B squared equals C squared. And always remember, when you're squaring something, you're multiplying it by itself. So A squared is just A times A. If you're working with numbers, 2 squared would be 2 times 2, which is equal to 4. So why is the Pythagorean theorem even important in HVAC? I'll tell you why. Skilled tradespeople use the 3-4-5 rule and the Pythagorean theorem all the time when squaring corners of buildings and components to ensure that they have a perfect 90-degree angle. So oftentimes when you're squaring corners, you may not know the distance of one of the sides, or you may need to know the distance of all three sides to get the perfect 90-degree corner. And so that's why we use it. So we're going to go over this at a high level to make sure you understand how the Pythagorean theorem equation works. So let's go over an example really quickly. Testing the 3-4-5 rule. Okay, so let's use the Pythagorean theorem to test the 3-4-5 rule. Remember, the 3-4-5 rule is a ratio where two sides can be 3 and 4, meaning the hypotenuse would be 5 units long. And that stands the test of time for any similar ratio. So say in the Pythagorean theorem, we know that A squared and B squared we know that A is 3 and B is 4, but we're trying to solve for C. So already, because we know the 3-4-5 ratio, we know that C is going to be 5. But let's prove it out. So 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16. So 9 plus 16 equals 25. So we know that 25 equals C squared. So we have to take the square root of C squared to get C. And as you know, in basic algebra, what we do to one side of the equation, we have to do to the other side. So if we take the square root of C squared, we get C. And if we take the square root of 25, we get 5. So C is equal to 5, proving out the 3-4-5 ratio. So let's go through another quick example. Say we know that A is 6 inches and we know the hypotenuse this time is 7.2 inches. We need to solve for B. So how do we do that? We plug the numbers into the Pythagorean theorem equation. A squared is 6 squared plus B squared, B is what we're trying to solve for, equals 7.2 squared. So let's solve it. 6 squared is 36, 7.2 squared is 52. So we need to isolate B squared. So we subtract 36 on this side and subtract it to the other side, because what you do to one side of the equation, you have to do to the other side. So there we have B squared equals 16. We take the square root of B squared and we take the square root of 16 squared. And you may not be able to see it because my head's in the way, but B equals 4. So there you have it. Concepts like the 3-4-5 rule and the Pythagorean theorem, they're unchangeable, they're immutable, they're always 100% true all of the time. So knowing these concepts will always come in handy in the construction world when you're dealing with angles and triangles. Thank you so much.